We'll take a break in a moment. If anybody, including me, needs to visit the restroom. Okay, so we're starting to record, and okay, so we're starting recording. Back to synapses. So a synapse is the gap between one nerve and the next nerve. The nerve impulse travels away from the cell body to the nerve ending, and neurotransmitters are released. So the structure of the synapse, this lists them. Let's look at a picture. So this is the presynaptic neuron. This is the postsynaptic membrane. The nerve impulse travels away from the cell body toward the presynaptic neuron, which is the end of the nerve. There's a gap called the synaptic cleft, or the synapse, and there's the synaptic cleft, and there are receptors on the postsynaptic membrane. Because once the nerve impulse travels to the end of this presynaptic neuron, these vesicles fuse with the membrane and release, say, acetylcholine or norepinephrine or dopamine. The biochemical neurotransmitter is released and causes the opening of sodium channels in this postsynaptic membrane, so that sodium can rush in and cause voltage changes, which can cause another nerve to continue the process, continue the movement of the nerve impulse, cause a muscle to contract, cause light to be sent into the retina and through the complex connections of the retina to the to the occipital lobe with the vision center. So electrical changes in voltage by movement of sodium into the presynaptic neuron causes a release of acetylcholine, and that can cause channels to open in this postsynaptic membrane. So after the synapse, before the synapse, and the transmission between nerves and muscles takes place by the release of a biochemical neurotransmitter, which opens channels in the postsynaptic membrane to allow for a neurochemical stimulation. And notice everything is based upon movement of sodium in, potassium out, and we'll learn that calcium causes the release of these vesicles able to fuse with the membrane and release the neurotransmitter. So this synapses are different according to the neurotransmitter that they release. Some release acetylcholine, which is destroyed by acetylcholinesterase, which breaks up the acetylcholine so that the channel can close and the muscle or the nerve can be ready for another nerve impulse or spike or action potential with new acetylcholine released. The channels close when the acetylcholinesterase digests or breaks up the acetylcholine. Other synapses are called adrenergic. They release norepinephrine. That happens throughout the autonomic nervous system. The dopaminergic synapses are involved in the brain, and when you have problems with these synapses, you get Parkinson's disease. So again, we can look at how the synapse of the presynaptic neuron and the postsynaptic neuron. So we have the action potential moving down to the axon ending. These vesicles fuse with the membrane. Calcium has to come in to do that. So acetylcholine is released from the vesicles. It causes the sodium channels to open, and then sodium rushes in, causing the voltage change So remember, this is an electrical event as the impulse travels to the presynaptic neurons ending to release the neurochemical acetylcholine or norepinephrine or dopamine. So communication at synapses is a biochemical event. That's why you can get high. That's why nicotine works. That's why LSD works. That's why speed works, because it modifies the biochemical event at the synapse. Okay, so the sodium channels have been open, and the depolarization happens at the postsynaptic membrane, and then acetylcholinesterase is going to break up the acetylcholine, and the action potential moves along the next nerve or the postsynaptic membrane. So presynaptic, postsynaptic, synapse. The biochemical release causes the opening of the channels, and the channels are closed, and the action potential moves through the muscle or into the nerve to cause voltage changes. What I mean by voltage changes, movement of sodium into the postsynaptic cell. When positive charge moves in, the action potential occurs because the cell membrane becomes, or the interior of the postsynaptic membrane becomes slightly positive, and that change allows sodium to move and open up more sodium channels by the change in voltage. Okay, we're not going to worry about that. Okay, so the synaptic terminal releases a neurotransmitter. It binds to receptors. There's a change in permeability of the postsynaptic cell, means that channels open to allow sodium in. Many drugs affect the nervous system by stimulating these receptors and produce complex effects on perception, motor control, emotions. So the fact that we have neurochemical neurotransmitters causing the voltage change in the presynaptic neuron to cause a voltage change in the postsynaptic neuron can be managed, everything from blocking conduction within the heart to slow down the heart, to getting high, as I said, on adrenaline, on speed and cocaine, and all the various drugs change what happens at the synapse as a biochemical event. Okay, let's stop there, and let's take a 10-minute break. So it's 8:38, so at 8:45 we'll come back, and I'm going to take a